In this lecture, we're going to begin discussing various processes that allow animals to live as part of a group. Right? Processes that allow them to, for example, communicate with each other, understand each other, and learn from each other. In this part, we're going to be discussing what's known as theory of mind, which some of you may be familiar with from, say, developmental psychology courses. So we're going to begin by discussing what theory of mind is and what role it plays for humans. And then we're going to begin exploring whether chimpanzees have any aspects of theory of mind, chimps being the most widely studied animal as far as this is concerned. So as we go through studies on chimpanzee theory of mind, we're going to discuss some studies where the chimpanzees have to cooperate with people in order to get food. And then we're going to move on to discussing studies where chimpanzees have to compete with each other in order to get food. And we're going to see that there's some evidence for at least rudimentary theory of mind abilities in chimpanzees when they have to compete for food instead of when they're cooperating with people in order to get it. So let's begin by discussing what theory of mind is and the role it plays in humans. Basically, theory of mind is our folk psychology. Right? It's the psychology that we use to explain and predict each other's behavior. Right? When we do this, we attribute mental states such as beliefs, intentions, desires, and knowledge to other people as well as to ourselves. And we make these attributions to understand each other's actions and also to predict what other people are going to do. And when we deliberate and reason about different situations, we often evaluate these mental states and reason using these mental states. So for example, Dan may have a beer that he wants to keep for himself, and as a result may reason as follows. So Dan may say, I want this beer for myself. By the way, I've italicized all the theory of mind terms. And these are terms that are intentional, right? They have an aboutness. They're about something. So I want this beer for myself, so I have to keep it out of sight of Rachel. If she sees it, she's going to know that I have beer, and then she's going to want it. Then she'll ask me for it, and I know I won't be able to say no. Okay, so this is a typical example of people using theory of mind concepts like wanting, seeing, desiring, and so on, right? So this should be very familiar to all of us. Now, humans develop theory of mind at about age 3 or 4, so there seems to be a strong shift in what people can understand about other minds when they turn about 3 or 4. And we can see this because young children at this age, they start to try to manipulate. They practice manipulating other people's mental states. Right? They try to play mind games with people, for example. So the question is, do animals possess theory of mind? Are animals capable of attributing to other animals mentalistic concepts and use this to predict their behavior? Well, having a theory of mind would obviously be useful for animals, right? One of the things that they would come to know by attributing mental states to other animals is that those other animals' representations of the world may not necessarily be accurate, right? They may not necessarily reflect reality. And they may be different from the animal's own representation of reality. So one of the things about having a theory of mind is that you, to some extent, separate the mind from the world. Right? You can see that there's a rift between what an animal thinks is going on and what is actually going on. As a result, but by knowing that there's this distinction between what's going on inside your head and what's going on out there in the world, animals would be capable of deceiving other animals, right, by manipulating mental states. right? So this brings us to the issue of intentional deception, right? So one of the things that theory of mind would allow an animal to do is intentionally deceive another animal. So by using the term intentional deception, I'm making a distinction with unintentional deception, right? So examples of cases of unintentional deception would be if an animal possesses camouflage, right? That's not an intentional act on their part. That's just the way that they're designed by natural selection, right? So by being camouflaged, they may deceive other animals, but we wouldn't attribute that to any kind of insight on their part about the minds of others. So what we're talking about is intentional deception. And this is when an animal acts with the goal of making the other animal misrepresent reality, okay, to have false beliefs. So we do this all the time, right? We intentionally tell other people things that are false. And the question is, well, do other animals engage in this kind of intentional deception? And one of the earliest researchers to report on this was Whitten and Byrne, and they discussed this topic at length. And one of the examples that they mention is a baboon who they named Melton. And what this baboon did was he would avoid being attacked by other baboons by all of a sudden acting as if he sees a predator, right? So he would freeze and look out into the distance as if his attention was caught by some predator in the distance. And when he did this, the other baboons would stop attacking him, and they would also look around to see if they could spot the predator, and hence forget what they were doing, i.e. attacking Melton. But one of the things that happens, as we've seen with other aspects of animal cognition, is that it's almost always possible to offer more deflationary explanations, right? So we said that the baboon is intentionally deceiving the other baboons by pretending that he sees a predator. So the animal would be thinking, if I get them to think that I'm seeing a predator, that will capture their attention away from me, and then I'll be able to be safe, right? But a more simple explanation is possible, right? So what we'll see is that animals may simply learn that by doing certain things in certain situations, they're more likely to get what they want and also avoid certain negative consequences, right? So a simple learning explanation may be involved instead of one that involves detailed understanding of other animals' minds. And what we'll see is that without experiments, we can't rule out these kinds of more deflationary explanations that have nothing to do with an awareness of other minds. So normally our go-to move is to study the situation in the lab where we can exact greater controls. But even here, the results can be inconclusive and they can be interpreted and explained in a more deflationary way. So one of the earliest lab studies on theory of mind was carried out by Woodruff and Premack. And in this study, a chimpanzee was seated behind a screen, and he sees a lab assistant hide food in one of two containers. But they couldn't reach the food, right? So they couldn't see where it was, or they couldn't reach where it was hidden. So the assistant, after baiting one of the two containers, would leave, and one of two distinctively dressed trainers would come in, right? So they were dressed differently to make them easily distinguishable. And so sometimes the trainer that would come in would be what they call the cooperative trainer, and other times it would be the competitive trainer that comes in. And what the chimp had to do was he had to point to one of the two containers to get the hidden food. So by pointing, the idea was that by pointing to the container, the trainer that came in would then get the food and give it to the chimpanzee. But here's the catch, right? If the chimpanzee points to the container that has the food in it, when the cooperative trainer enters, the chimp gets the food, right? So he points to the cup that he wants to get the food from. The cooperative trainer reaches in and then gives it to him. But if he does that when the competitive trainer comes in, then the competitive trainer takes the food and keeps it for himself, right? And doesn't give it to the chimpanzee. So what do the chimps have to do? They have to point to the right container, depending on who's coming in, whether it's the cooperative trainer or the competitive trainer. And the chimps eventually learned to point to the proper container, right? So if the competitive trainer came in and they pointed to the empty container, later on they would get the food. If they pointed to the container that had the food when the cooperative trainer came in, then they would get the food directly. So the results were that the chimp learned to respond appropriately, pointing to the correct container depending on which trainer came in. Right? So they argue, Woodruff and Premack argue, that this shows a theory of mind understanding on the part of the chimps. Right? They say that the chimps understood that one trainer was of a cooperative frame of mind. And that's why when this trainer came in, they pointed to the cup that had the food in it. And they also understood that the other trainer was not of a cooperative frame of mind, so they would point to the other container and then get the food later on. Right, so based on these attributions, they learned that to get the food when the competitive trainer is present, they would have to deceive him by pointing to the other container, the one that's empty. But what are some of the problems with this interpretation? One problem is that it took them, on average, 120 trials to figure out which container to point to get the food in each case. Right? So this doesn't seem consistent with, this idea that they have an insight into the mental states of the trainers, right? Whether they're cooperative or competitive. Right? If they did understand the mental states of others, shouldn't they have arrived at an answer much more quickly? Right? It seems as though that's the case. But also, as I mentioned at the start, it's possible to offer more deflationary explanations of the results. Right? You don't need to attribute theory of mind to the chimpanzees to explain how they figured out which container to point to, the one that's empty or the one that has the food in it. It could simply be a matter of associative learning, right? They may have learned that if the guy that's dressed like X, right, if the guy is dressed like X, then point to container A to get the reward, and if the guy is dressed like Y, then point to container B to get the reward. Right, because as I said, the two trainers were dressed differently so that they could be easily distinguished. Now, as you look at this interpretation, this requires no insight into the trainer's mental states. Right? The interpretation simply requires that the chimpanzee learn a rule about observable or behavioral regularities. Right? It doesn't require any insight into mental states. And this kind of associative learning explanation seems more consistent with the fact that it took so long to get the animals to respond accurately in each case. All right, so to properly attribute theory of mind abilities to animals, we need to be able to rule out other explanations of the results that don't appeal to theory of mind understanding. So we have to rule out explanations that simply require them to make decisions based on behaviors that are observed or other observable features of the situation. Right? So these alternatives, these more learning types of explanations require only general learning mechanisms, which we've discussed already and which we know animals possess. Right? They don't require special machinery like theory of mind mechanisms. So because these more general explanations are possible, they're more desirable given Morgan's canon. So as another attempt to explore theory of mind abilities in chimpanzees, I want to discuss a study by Povinelli, Nelson, and Boysen, another classic. This one asks whether chimpanzees attribute knowledge to other people. Can they attribute who knows what? Rather than intentions of being cooperative or competitive, can they attribute knowledge and ignorance to other people? So do they know who knows something and who is ignorant? Now that seems abstract, but when you get through the details of the study, you'll see what I mean. So this study presented chimpanzees with 4 cups, and one of the cups was baited with food. Now the chimps themselves didn't know which cup was baited, but if they chose the correct one, they got to eat the food. Right? So to help them figure out which cup to point to, they had 2 trainers that could help them. Right? So 2 trainers helped with the choice by pointing to a cup. So you can see the chimpanzee in the picture. There's the 4 cups, and you can see the 2 trainers. Each one is pointing to a different cup. You can see one trainer has a hat and the other doesn't, making them easily distinguishable to the chimpanzee. So one of the trainers was labeled the knower, while the other was the guesser. Okay, so one knew where the food was hidden, the other one was only guessing. Before each trial, the guesser had to leave the room while the knower hid a piece of food under one of the cups. And the chimp couldn't see which cup was being baited, as I said. And after the cups were baited, then the guesser returned, and then the knower pointed to the cup that he had baited. The guesser pointed to another cup, and the chimpanzee had to choose which of these cups would have the food. Right, so if the chimps can attribute knowledge to others, right, they should be likelier to choose the cup that's pointed at by the knower. After all, the knower is the one that's in a position to know where the food is. And after many trials, all chimps came to prefer the cup pointed at by the knower. But as with the previous experiment, it required hundreds of trials for the chimps to be able to respond, to develop this preference and respond accurately. But again, more deflationary explanations of the results are possible, ones that don't require chimpanzees to have an insight into the mental states of people. So what's an alternative explanation? Well, for example, the decision could have been made as follows. Choose the cup that's pointed to by the person that was in the room the longest, right? Or choose the cup pointed at by the person who last touched the food, right? Each of these would be consistent with the evidence available to the chimpanzee, and importantly, don't require them to have knowledge about the mental states of the individual trainers. And as I said before, this is consistent with the long training period that's required in order to get chimps to respond correctly. All right, so far we have reasons to doubt that chimpanzees have much insight into the mental states of others. The results can always be interpreted in a more domain general fashion, or more general learning with more general domain general learning mechanisms. But there are limitations to the studies that we discussed. First, they examined whether chimpanzees can attribute mental states like knowledge and ignorance, cooperative versus uncooperative, to humans, right? Not to other chimpanzees. So we're studying cross-species theory of mind, which is different from within-species theory of mind. Another problem is that the tasks have been set up to require chimpanzees to cooperate to get food, in particular to cooperate with humans to get food. But usually food is a competitive venture for chimpanzees, right? Usually the alpha male dominates the food, eats whatever the hell he wants, and the subordinate chimpanzees have to fight with each other, compete with each other in order to get whatever food's left. So this led to what's called the competition paradigm in exploring theory of mind abilities. I'm going to discuss an experiment by Hare, and Tomasello, another classic, which looked at theory of mind abilities in chimpanzees, taking into account these limitations of the previous studies. So they examined chimpanzees' abilities in contexts where they had to compete with each other to get food, and the two chimps were used at a time, one being dominant relative to the other. So one was dominant and the other one was subordinate. And both were on opposite sides of a test area, each in a separate cage. Okay, so you can see the setup here. You can see the dominant chimpanzee is in one cage, the subordinate is in the other. And you can see there's screens in the common area, which they called occluders, and food is placed behind one of these screens. Okay, so what they did was they manipulated whether or not the dominant chimp could see whether food was hidden. Okay, so food was placed behind one of the occluders using a mechanical hook, right? And importantly, the subordinate could always see where the food is being baited. Right? They could always see where the food is being hidden. Right? This is because the door to their cage was always partly open so they could see the rest of the test area. What they manipulated was whether or not the dominant animal could see the baiting. So sometimes they could see where the food was being placed, other times they could not see where the food was being placed. So they're manipulating the knowledge of the dominant animal, and supposedly the subordinate animal can see this manipulation. Okay, so sometimes the cage door was partly open and other times it was closed for the dominant animal, allowing them to either see or not see the baiting process. Now they had two sets of trials in their experiment. In the first set of trials, the main manipulation was whether the dominant animal was informed or whether they were uninformed. In the informed condition, the dominant animal can see where the food is being placed because their door is partly open. And in the uninformed trials, the dominant animal cannot see where the food is placed, right, because their cage door is closed. In the second set of trials, the dominant animal was either informed or misinformed. Right, so the informed condition was as in set 1, right? They can see where the food is hidden because their cage door is open. And then in the misinformed condition, the food is hidden in one location, which the animal can see, and then it's moved to another location once their cage door is closed. Right, so when we're talking about the manipulations, we're talking about the manipulations for the dominant animal. So keep in mind that the subordinate chimps can see all of this. Right, they can see what the dominant chimps can see and can't see depending on the trial. So the subordinate animals, so the two cages were opened and then they allowed the animals to go out there and get the food. but the cage door for the subordinate animal was opened a little bit before the one for the dominant animal. Okay, and what they did was they recorded the likelihood that the subordinate animal would not even try to approach the food. Right, so did they move in the direction of the food, or did they not move in the direction of the food? The other thing I want to point out here is the few trials that were used. Right, there was 4 trials per condition for a total of 16 trials. And this is what they found. So the y-axis is the probability of the subordinate animal not trying to get the food. Right, so they do not move in the direction of the food which they saw hidden, right, as a function of each of the 4 conditions that the dominant animal was in. So as I said, set 1 compared when the dominant animal was informed versus uninformed. And what we can see is that when the dominant animal was informed, right, they saw it being hidden, the subordinate animals were less likely to make a move towards the food compared to when they saw that the dominant animal was uninformed. Okay. So when the dominant animal was informed, the subordinate animals were less likely to make a beeline for the food. So they were more likely to not try to get the food. Likewise, with set 2, where they manipulated whether the dominant animal was informed versus misinformed, the subordinate animals were much more likely to not try to get the food when the dominant animal was informed compared to when the dominant animal was misinformed. So they're not even going to bother, right, to try to get the food when the dominant animal is informed. All right, so the subordinates were more likely to not to attempt to get the food when the dominant animal was informed than when he was uninformed, and likewise they were more likely to not attempt to get the food when the dominant chimp was informed than when he was misinformed. All right, so this suggests that the subordinate animals have some awareness, some insight into what the dominant chimps know. Right? They seem to be aware of whether the dominant animals know where the food is or don't know, either because they were uninformed or misinformed. And they use this information to decide whether or not to try to get the food. If they think the dominant animal is informed and knows where the food is, they're not going to bother trying to compete with the dominant animal. And these results are noteworthy because of the few trials that were involved. Right? It's unlikely that a gradual, slow, associative learning process was involved. Instead, it seems like evidence of true insight into the mental states of the dominant chimpanzees. All right, so the present thinking is that chimpanzees have at least some theory of mind abilities, although they may not be as extensive as ours. Of course, ours are facilitated by language, right? With language, we can create much more elaborate chains of reasoning about mental states. So they seem to be able to monitor what others see and hence know about their environment. But these abilities, these rudimentary theory of mind abilities, are more likely to be brought out in competitive situations where they're competing with each other for access to food, instead of being evident when they're trying to cooperate with humans in order to get access to food. Now, just in closing, I want to point out that theory of mind has been studied in other species as well, in particular in avian species. So, for example, Daly, Clayton, and Emery studied western scrub jays, right? And scrub jays, as we've said before, are birds that like to cache their food, right? So they collect food and then they bury it, and then they remember where they buried it so they can get it later. And what they found in this naturalistic study is that these western scrub jays, if they're burying their food, if they're caching their food, and all of a sudden they realize that another bird has seen where they're caching this food, right? They're more likely to recache their food. They're more likely to go and hide it somewhere else, right? So they'll dig it up and then bury it somewhere else. And this suggests that they're sensitive to what other animals know and don't know, right? And similar findings have been discovered with ravens.